Hello, everybody, and welcome to our first lesson of factoring. This is actually the first lesson that we have not done in school, and so it is very important that we are hopefully paying attention and going over some of the things that we are going to be talking about, because factoring is something that's going to be incredibly important in the lessons going forward. So it's very crucial that we have a strong foundation for factoring now, so that when we get to more complicated applications with factoring, we know how to do it. Again, so some of this hopefully we have seen before in grade 9, but if you haven't, that's really fine. We're going to start new here. So again, factoring is the opposite operation to expanding. So the last video we saw, that when we expanded, so I have actually the things here, when we expanded, we kind of removed the brackets. So for this question, we expanded the 2, or we distributed the 2 inside the bracket, so the bracket was gone. Again, we distributed the 2x inside the bracket, so the bracket was gone. Factoring is kind of the opposite. We want to introduce a bracket, or we want to group something out of all the terms that are present here. So, or well, maybe some of the terms, but we're going to consider first all of the terms. So we have to identify what is common here between 9x and 6. Again, we should get used to thinking, when I say what is common, in terms of multiplication and the factors that are present. So what are factors? Factors are anything that multiply to give you 9x. So again, we're going to find the factors that are common between 9 and 6. And hopefully we can see that between 9 and 6, the greatest common factor is 3. Right? Because an easy way to check that is pick the smaller number, which is 6, write out all the factors of 6, and see which is the biggest one that also goes into 9. So 6 doesn't go into 9, 3 goes into 9, so that's your answer. And that is almost uniformly the easiest way to find the greatest common factor if you don't see that intuitively. So start with the smaller one, write all the factors out, and see which is the biggest factor that also goes into the other number. Hopefully we're okay that, what was I going to say? I can't remember. It'll come to me later. But again, that was the number that I'm taking out. And now what I'm going to do is I've technically factored out, I'm trying to factor out a 3 from both of these terms. So I'm going to take out a 3 from both of these terms. And again, we are thinking in terms of division. So take out as in divide out a 3 from both of these terms. So 9x divided by 3 is 3x. Negative 6 divided by 3 is negative 2. So what I've done is I've technically divided both these terms by a 3, and I can't just divide by a 3. So what that means is I've taken out the 3, I've divided out a 3, and so what is left after my division is inside the bracket. And hopefully we'll see that this makes sense, because if I try and expand this, so if I do your normal multiplication, you'll see that I get back my original expanded form. And this should always work. When you factor, if you expand back, you should see that it goes back to the original expanded form. So again, some more factoring practice. How do we factor variables? The variables can be factored by the same letter, the same kind of variable. So you can't, if you have like an x squared minus y, there's nothing in common here. But we'll see here that x squared and x squared is basically x times itself, and x is just 1x. So we see here that there is an x that is common. So whenever we have two variables with the same letter, the factor that comes out is the lowest power. So here we have x to the power of 2, here we have x to the power of 1. What I'm doing is x to the power of 1 is my common factor, is my greatest common factor that I can take out. And again, Same procedure. After I've taken out my greatest common factor, I'm gonna open a bracket, and inside that bracket goes whatever this was divided by x. So x squared divided by x was x. X to the power of 1 divided by x with the minus sign was -1. So my answer is x times x minus 1. And hopefully we see that if we do expand this, we get back original x squared minus x. So we know that we've done it correctly. All right, let's look at this. Again, let's try and factor our number first. So I have 15, 20, and 35. So let's look at 15. That's my smallest number. My factors of 15 are 1, 3, 5, and 15. These are the numbers that multiply to give me, 15. So 15 doesn't go into 20, so that's out. 5 goes into 20, so that's okay. 5 also goes into 35. So that is my greatest common factor in the number part of it. And then I look at my variables. I have x to the power of 3, x to the power of 2, x to the power of 4. My lowest one is x to the power of 2. Y to the power of 2, y to the power of 3. My lowest one is y. So that's going to be my greatest common factor. And inside the bracket, what I'm going to get is this term divided by my greatest common factor, because I have divided out a greatest common factor from each of these terms. So once you do the division, 15 divided by 5 is 3. 3 minus 2 is 1. 1 minus 1 is 0. So y to the power of 0 is 1. So I'm not writing that. Again, this divided by 5x squared y. Minus 4. 2 minus 2 is 0. 2 minus 1 is 1. Divided by 5x squared y. Plus 7. 4 minus 2 is 2. 3 minus 1 is 2. And so this will be my factored form of this expression. So hopefully we're okay with that. Where was I? Oh, I missed C over here. Whoops. Sorry, we'll come back to C. Here again, my number is a -4 and a 16. And this is going to be a rule. Whenever we have what's important is going to be the variable with the highest power has this kind of importance when we factor things. So here we see that the y squared is the highest power. So this term has the highest power. I always want that term to be positive whenever I do. So what I'm going to do is, even though 4 and 16, my factors are 1, 2, and 4, 4 goes into 16, so that's what I'm going to take out. I am going to take out a -4 along with it, because this y squared term is a negative, so I'm going to take a negative out with that. Again, y to the power of 2, y to the power of 1, I'm going to factor out y to the power of 1, and then I'm going to do division. So this leaves me with a y, this leaves me with a -4. And so this is what my answer should be, -4y bracket y minus 4. And the idea is, if I hadn't factored a negative out, my bracket would start with a negative sign, and ideally I don't want that to happen. So that's why I do factor out a negative when the highest power of the variable is a negative. I try and factor that out, and if the question is factor. That's just a good form when you're writing stuff, so it's important to note that going forward. Again, we're going to look here, and we can see that our highest power is technically this, because it's 3 plus 3, but in these kind of things, it's not much of a hassle. You don't really need to factor out a negative. And we'll explain why that is here. So the factors of 8 is 1, 2, 4, and 8. So let's see here. 8 doesn't go into 12, so that's out. 4 goes into 12, but it doesn't go into 26, so that's also canceled. Remember, it has to be common to all three. So 2 goes into all of these things. So 2 is the only number I can factor. Again, I have a to the power of 4, a to the power of 3, and there's no a's here, so I cannot factor out any a's, because again, I have 0 a's here, and I need it to be common among all the terms. B to the power of 3, so I can factor out a b to the power of 1, and then I'm going to divide everything by 2b. So here I have 13a to the power of 4 minus 4a to the power of 3b squared plus 6b to the power of 3. So this would be my factored form. And hopefully, as you can see here, the key was the first term that I'm writing in my bracket this first term should be a positive. Ideally, you want to keep it like that. And since this is, we don't have to factor out a negative. Okay, this is hugely important when it comes to decomposition. So it's essential that we learn how to do, proper common factoring. So let's look at this here. So this is an interesting case because, again, let's see what we're multiplying in both of these terms. So here we have this term and here we have this term, right? So here we have a 5 multiplied by an x multiplied by a y minus 1. That's my 3 components of this first term. Here I have a negative 3 multiplied by a y minus 1. And we can see here that what is actually common is the y minus 1. Right? So that's the term that is present in both this and this part of the expression. So that is what I'm going to take outside my bracket. I'm going to take a bracket outside a bracket. And I know that's kind of like confusing at first, but hopefully we see, again, we're looking for things that are common between this and this. And we'll see here that the only thing in common is the y minus 1 part. So I can factor that out because I can divide both of these things by y minus 1. And what I'm left with here is a 5x. If I divide this side by y minus 1, what I'm left here with is a negative 3. So this is my final answer, y minus 1 times 5x minus 3. So again, very important to practice this. Again, we can see the same kind of process here. 8 times x plus 3, negative 2 times x plus 3. So again, I'm looking for something in common between this part and this part of the expression. And what I can see here is that I do have an x plus 3 that is common in both parts. What I also have common is I have to look at the numbers. I have 8 and a 2. So the factors of 2 are 1 and 2, and I see that 2 goes into 8. So I can factor out a 2 and an x plus 3 out of these terms. So I can divide this by 2 times x plus 3. This also I can divide by 2 times x plus 3. So this goes away. Then I'm left with 4x here. I'm left with minus 1 here. So this is my final factor form in this expression. So hopefully we see what we're doing. We're looking for things that are common between my two parts, right? This part and this part. And I see here that I have an x plus 3, that bracket is common. So I can factor it out. I can take it out and divide both parts by that x plus 3 bracket. And after I do the division, that's what goes in my other bracket. So hopefully we'll see how we are doing this, and we're okay. Solve for the indicated variable. This is, again, an extension that you will not necessarily see a lot of in the coming unit, but it's hugely important in the later units. The later half of the coming unit, I should say, and obviously in grade 11 and 12, you're going to be using this endlessly. So it's important that we know what we're doing here. The idea is that we're trying to solve for h, but we have two different h's present over here. So we don't really like that. What we're going to do here is we're going to factor out an h from these two terms because I see an h that is common. And whenever I'm isolating for something, I want only one of it so that, it's on its own. So I'm going to factor out an h. I'm going to divide both sides here. So I'm left with a minus b, or both parts, I should say. And then because I'm isolating for that or solving for that, I can divide both sides by the a minus b bracket that is technically on this side because I want to, cancel out like this. So I get h equals 2 capital A divided by a minus b. This would be, and this is my final answer. Hopefully we can see what we're doing here. We're trying to isolate for a. I have two different a's here, so that's not good. So first thing I'm going to do is bring them to one side, very important. I can't factor if they're on different sides, so I'm going to add 3a to both sides. And then I'm going to factor out an a from both these terms. So what I'm left with here is 5c. I'm left with a 3 here. R on this side, divided by 5c plus 3, divided by 5c plus 3. Again, the 5c plus 3 here is multiplying into the a, so I can cancel that out. I have a equals r divided by 5c plus 3, and this is my final answer. So hopefully we're good with solving for indicated variables. Again, these are relatively harder questions. We're gonna try and do some of them here, but I don't know. Okay, I'm too lazy to actually download page number 230 and see what's on it. But hopefully there's practice similar to these kinds of questions that you are doing, because this is hugely important when we get to decomposition and stuff. But okay, let's look at this one. So this one's a bit interesting, right? Because here, what we really have is 2 to the power of negative 4, 2 to the power of negative 6, 2 to the power of negative 3. I have a plus here, so I can't just do negative 4 minus 6 plus 3 or something like that, because I have an addition sign and there's no way to combine exponents with addition signs. So what we're going to do is we're going to factor out something, and that's going to be actually a 2 to the power of negative 6. So again, imagine we've done questions where we were doing like x to the power of 4 plus x to the power of 6, and we were taking the lower power and we were factoring it out, right? And then we divided both sides by that thing that we factored out. Here, again, the same idea, except instead of an x, there's a 2. No big deal. We're just going to treat it the same way as like we would any other variable. And the lower number here is actually turns out to be negative 6. So that's what we're going to take as our factor. Again, I'm still only working in the numerator. I'm ignoring the denominator for now. That still stays 2 to the power of negative 3. I'm not touching that. Okay, now what am I left with when I do 2 to the power of negative 4 divided by 2 to the power of negative 6 is negative 4 minus negative 6. Minus of a minus becomes plus, right? So I actually have negative 4 plus 6, which is 2 to the power of 2. And 2 to the power of negative 6 divided by 2 to the power of negative 6 is 2 to the power of negative 6 plus 6. Again, this was a minus of a minus 6, which I made plus 6, 2 to the power of 0, which we see is 1. So that's what that's going to be. So here I can actually calculate 2 squared plus 1 is 4 plus 1 is 5. So I have 2 to the power of negative 6 times 5 divided by 2 to the power of negative 3. And I can, again, simplify here because I have two parts with the same base. So I can combine the exponents. This becomes 2 to the power of negative 3 because I did negative 6 minus negative 3 here, which became negative 6 plus 3 times 5. 2 to the power of negative 3 is 1 over 2 to the power of 3 times 5. 1 to the power of 3 times 5 is just 5. 2 to the power of 3 is 8. This is my final answer. 5 over 8 is the correct evaluated form of that question. And I know that was slightly tricky, but hopefully we see that it was basically comprised of simple steps that we could use in order to get that. Okay, so the next little bit here that we're going to do is this question. Again, here we have a subtraction in the numerator, addition in the denominator. So first I'm going to work with the numerator, factor out the lower part, which is 112. What I am going to do is divide both by, I'm going to technically divide by a negative 112. So that's, both I'm going to do minus negative 112 minus negative 112. This is going to give me 4 to the power of 0 or 1. This is going to give me 4 to the power of 1, which is, this should be a minus. 4 to the power of 1 there. And here I'm going to factor out the lower number, which is again 112. This is again going to subtract negative 112, going to subtract negative 112. This here becomes 4 to the power of 2. This here becomes 4 to the power of 0 or 1. And so again, I'm going to first, you could combine it here, but I am going to write it out so that you clearly see that 1 minus 4 is negative 3. This is still 112. 4 squared is 16 plus 1 is 17. 112 minus negative 112 comes from moving this term up. Again, I'm collecting things with similar bases or same bases. And here we get 4 to the power of 0, which is just 1, times negative 3 divided by 17, which is just negative 3 over 17 is my final answer there. Again, I will leave these to you. We've done similar questions above, so you can practice those on your own. But I will go over these, the question 1 part again, just because that's going to be kind of important for us going forward. So we need to know how to do that. So here we can see again, what are the things that are common, or what are the factors, I should say, that are common between this and this. So that's what we are looking for. So first the numbers, 3 and 6, I see that there's a 3 common. Then my variable part, which is an x here, there's no just a single variable there, so that's not common. And here I see there's a 2x minus 1 bracket, 2x minus 1 bracket. So there is a 2x minus 1 bracket that is common between these two parts of the expression. So here I can do divided by 3 times 2x minus 1 divided by 3 times 2x. Again, when I factor something out, what I mean is I'm dividing it out. So I will divide out whatever I factored out of each of the terms. So here we're going to cancel that. We're left with x. Here we're going to cancel that. I'm left with plus 2, and this is my final answer. Whenever I've asked to factor fully, never expand within a bracket. So some of you might be tempted to actually multiply the 3 times the 2x and 3 times the negative 1. Don't do that, because that is the opposite of factoring. You're literally going in the other direction as you are supposed to be going. So don't do that. Factoring means you want everything in brackets, and you want to make it into as many brackets that are multiplied together as possible. So I have 3 times this bracket times that bracket, and that's ideally what I want in a factored form. Again, same idea here. The number that's common is a 2. So there's no single variable that's common. The bracket that is common is a 2x plus 3. So what's left here after I divide out what I factored is an x. Minus 5. And this is, again, my final answer here. Again, hopefully we can try these 2 questions on our own. If you have any follow-up questions, again, you have the answers to these questions, and we've done similar questions, so hopefully you can see the thought process behind what we are doing. But if you, of course, have any questions, leave a comment below, and I will get back to you. I'm checking the channel pretty regularly, since all the coming lessons will most likely be done in a format similar, if not the same as this one. So, all right, good lesson, everybody, and I will talk to you soon. Peace.